To the 2017 World Dairy Expo. My name is Keith Sather, and I'm with Feed Supervisor, and I've got some bad things going here with my mic. Anyway, we at Feed Supervisor are really excited to sponsor today's seminar, Limiting Mold and Mycotoxin Problems in Dairy Herds. And, you know, I've had personal experiences working with Dr. Lon Whitlow, our speaker for today, and he's helped a lot of our clients. Dr. Whitlow is Professor Emeritus at North Carolina State University. Mycotoxin and molds in forage wreak havoc on a dairy cow's production and health. And I think we all know that there's a big deal out there, which is why you're here today. These issues are things that Dr. Whitlow will focus on, and that is the impact that mycotoxins have on the digestive system and immunity of dairy cattle. He will cover relevant information regarding feed handling, specifically for silage and prevention and treatment methods for molds and mycotoxins. Dr. Whitlow has done his extension research work in applied nutrition and mycotoxin issues, and through his research has discovered that mycotoxins routinely occur in a variety of feedstuffs, and that specific feed additives and management practices are effective in reducing mycotoxin toxicity and milk residues. This seminar has been approved for continuing education credits, and there are forms in the back that you can pick up when you leave if you would like those for both ARPIS and veterinarians. And with that, one reminder, if you have a cell phone with you or a smartphone, please mute them, turn them off, and also everyone would appreciate before you leave if you would fill out the Expo evaluation form. So with that, Dr. Whitlow.
Thank you. Appreciate you reminding me about my phone. I have made presentations in the past where it rang while I was standing up here. That's not good. But I do appreciate the opportunity of being here today to talk to you about mold and mycotoxin problems, one of my favorite subjects. I want to thank the program committee for inviting me, and I certainly want to thank the Feed Supervisor software group for the sponsorship of this presentation today. Now, you can hear me in the back all right? Can you understand me? I moved to Tennessee, and it's it makes it difficult sometimes for people to understand me. I want to start with a little bit of background information about mycotoxins. We've known about molds since biblical times, at least. There's references in Leviticus in the Bible about molds and how to handle food to prevent mold. In the Middle Ages, we had a problem in Europe with ergots, and the ergot problems have been seen off and on through the ages. It was not until the 1900s that we really found, that researchers identified some mycotoxins in moldy feed. They knew that moldy feed was not good, but they didn't know what the toxic principle was. And then in 1928, Dr. Fleming discovered penicillin, penicillin being one of the mold metabolites classified as a mycotoxin. And of course, that stimulated a lot of research along the line of finding compounds produced by molds that might have some value in medicine. And indeed, there's a whole list of mycotoxin-produced chemicals. These statins that you take for cholesterol are produced by molds. So there's a lot of chemicals that have been used in medicine that are produced by molds. In the early 1960s, moldy peanut meal was shipped to Britain from Brazil, and they had what they call turkey X disease. Turkeys had a lot of disease problems. So they did a lot of research with aflatoxin at that time, and unfortunately they found that it is a carcinogen. But not only a carcinogen, it's transferred from the feed into the milk. So that's a big issue for dairy, because we can't really tolerate having a carcinogen in the milk. So there was a lot of legal activity associated with that so that we regulate aflatoxins to very low levels in feed to prevent residues in milk. And of course, most of the aflatoxin problems occur in warmer climates. We don't see it very often in the northern region of the US or into Canada. Just every 15 years or so, like we had here in Wisconsin 5 years ago, I believe it was, we had aflatoxin issues. Then in the late 60s and 70s, we started finding other mycotoxins and some field cases that indicated that these other mycotoxins might indeed affect dairy cattle. And the latest important mycotoxin, fumonisin, was discovered as affecting horses back in 1988. Now, I graduated at the University of Wisconsin in the late 70s. I went to North Carolina, and I wasn't trained as a nutritionist. I didn't intend to get involved in mycotoxins. But once I got to North Carolina, dairymen started calling me, and I was working in extension. I had to answer their questions, and they wanted to know why they had gotten moldy feed and cows would not eat and so forth. Well, we didn't know much about mycotoxins at that time. We did have a good group of mycotoxicologists at North Carolina State. They worked in poultry. And they encouraged me to do research in dairy cattle because I would call them on the phone and I'd say, I got a dairyman that's got moldy feed. Can you tell me something about it? And they say, we really don't know nothing. You need to do research. So they did encourage me to get involved because we really did not know much at that time in the late 70s. And indeed, we continued to do some research then to show that mycotoxins do occur routinely and they do affect dairy cattle. Now, the fungus family is made up primarily of yeast and mold. The yeast are single cellular organisms. They grow by and reproduce by budding. On the other hand, the molds grow vegetatively, extending these hypha and then producing spores by which they reproduce. We see both yeast and mold growing, of course, in silages and other wet feeds. We see them in the field and otherwise. There's a lot of different molds. These are some of the non-toxigenic molds in that they do not produce a poison. We see a lot of these, mucor in particular, in silage, this white mold. We also see it sometimes on the outside of hay bales or wet grain or things of that nature. It does not produce any toxins. And about half to 2/3 of the molds that we see on feed are non-toxigenic. Now, the toxigenic molds are primarily aspergillus, penicillin, and then a variety of fusarium. We see a lot of these molds in the upper Midwest associated with ear rot and stalk rot in corn, and also with scab in small grains. I'm oftentimes asked about corn smut. Now, corn smut is a fungus. It is not toxic, but it grows under some of the same conditions where we see mold growing. And of course, it's very obvious when you have corn smut, you see that. You don't necessarily see the other molds. But smut is non-toxic, it's edible. As a matter of fact, it's very good. In some parts of the world, it is a delicacy, and you can see here a dish that's been made with corn smut. They did try to develop that as a food in New York several years ago, and it just didn't make it. I guess, you know, if the wife calls up and says, stop by the grocery and get me some smut, you know, it probably doesn't go over very well. They didn't make it. So why are molds and mycotoxins important to dairy producers? Well, they lower performance in the herd. They cause health problems, poor health, increased disease. So you get a higher culling rate, you get an increase in death rate, and they reduce profits. So that's far enough to go. That's 3 good reasons why we need to be concerned about it in dairies. Now, like politics, mycotoxins are local. Depends on the local situation. There's large seasonal effects. Some years we have more than other years, primarily related to weather conditions and plant stress. During drought conditions, we see more aflatoxin and fumonisin. In wet conditions, we see more DONs, zuralenone, and T2. There's regional differences. We see ergots in the northwest United States and on into the western Canada. We see it also as an endophyte in grasses, pretty much anywhere in the country, but particularly in the south. We see aflatoxin in the warmer, more humid climates. Penicilliums grow in a cool and moist climate. And the fusariums, a lot like the aspergillus or aflatoxin, we see the fusariums pretty much everywhere, really. Some of them like wet conditions more, some of them like dry conditions. Historical incidence in your region is a good indicator. If you see other dairymen, if you've seen this in the past, that's a good indicator that you might have the problem in the future. If you see field rots, then, or fungal disease in the crop, this is a good indicator that you may have some molds and mycotoxins. Storage contamination also is going to depend on getting that feed inoculated with spores, then feed conditions and storage management. So keep in mind that every silo and feed bin has its own microclimate, and that's going to affect mold growth and mycotoxin formation. So you could have this stuff grow anywhere because it depends on that microclimate that's in the feed storage, wherever you may be. Okay, this just gives you some indication of the incidence or occurrence of different mycotoxins. This is work we did in North Carolina over a 13-year period, just looking at the incidence of various mycotoxins. I've got the total incidence level here in blue, and then down below it is the incidence level at levels of concern in the feed. So you see, even in the south where we have aflatoxin, about 4% of the feeds had levels of concern, but you look at a mycotoxin like DON, about a fourth of the feeds had levels of concern. Fumonisin, 9%, T2, 6%, zuralenone, 8%. Now you take a mycotoxin like T2, very, very potent. So even though you have a fairly low percentage of the feeds contaminated, if you have that toxin, it's very, very potent and will cause problems. Mycotoxin concerns have perhaps increased, maybe because of agronomics and weather conditions, certainly because we're seeing more monoculture, corn on corn, corn following small grain. This is increasing the amount of recycling, if you will, or spores that recycle on the field and contaminate the new crop. Tillage is important, we'll talk more about that, but going from moldboard plowing to no-till has greatly increased the incidence of molds and mycotoxins. Certainly there's more awareness, we just have done more research, we have more field experience, so people are talking about it a little bit more. That certainly increases the idea anyway that there maybe the incidence has increased. Analysis is better, it's cheaper, it's faster. And then the cow, I think, is also important in that with a high-producing cow, we may have lower mycotoxin degradation in the rumen. The rumen destroys a lot of the mycotoxins that are in the feed. So cows aren't affected as much as pigs and chickens. But with this high-producing cow, turning the rumen over faster, we have less time and opportunity for the mycotoxins to be destroyed. Fewer protozoa, they're very important in destroying mycotoxins. So we're feeding a lot of grain, we're reducing protozoal numbers. Low fiber diets, low pH, acidosis. Low pH reduces destruction of mycotoxins in the rumen. And just high-producing cows may simply be more susceptible because of the stresses on that high-producing cow. So there are two problems with molds and mycotoxins. The first one is called a mycosis. A mycosis is a disorder resulting from a fungal infection. The mold itself infects the animal. It can infect the skin, maybe the lung, causing pneumonia, digestive tract, The reproductive tract, we have a considerable number of fungal abortions associated with mold infections, and then fungal mastitis as well. So there can be a number of different aspects of fungal infections. The ones that a lot of people have heard about and maybe dealt with in more recent years has been this hemorrhagic bowel syndrome. And that's associated with Aspergillus fumigatus, where the mold itself will infect the lining of the gut, cause hemorrhage, the formation of a blood clot, and then sudden death in the cow. The cow looks normal one day, she's down dead the next. This is a multifactorial disease where the Aspergillus interacts with mycotoxins. It interacts with clostridial toxins to gain entrance into the tissue and then cause this infection and hemorrhage. So it is a multifactorial disease. And keep in mind that the Aspergillus produces a number of different mycotoxins. Some of these very, very important. This gliotoxin, for example, that pretty much knocks out immunity in the animal is quite important. And one of the reasons why the Aspergillus can infect the lining of the gut, because it knocks out the immunity of the gut. Okay, the next aspect then is mycotoxicosis. This is a disorder where the poisonous effects of mycotoxins that are produced by the fungi can affect the animal. So the mycotoxin is a chemical, and the mold is the organism. So the organism, the mold, produces a mycotoxin that's simply a poison that then can affect the cow. The way I look at mycotoxins affecting dairy cattle is that there are multiple mycotoxins in feed. This is especially true of silages. There's some very unique mycotoxins there in silage. Some of these mycotoxins are toxic to the rumen microbes. They can cause ruminal upsets, acidosis off feed, reduce the digestibility of the diet, alter VFA production. And then again, in the high-producing cow, as we mentioned, we probably see less destruction of the mycotoxin because of rapid rumen turnover and low pH. In some cases, the mycotoxins that we do, that are ingested by the cow, are converted to even more toxic derivatives in the rumen. This is an example of that would be zearalenone. Zearalenone is converted to zeranol, which is even more toxic than the zearalenone to begin with. Some of the zearalenone is destroyed, but some of it gets converted to zeranol. So you do have instances then of producing more toxic derivatives. The flow then of these mycotoxins to the gut, where they can be absorbed, they interact with all of these stresses on the cow to cause a mycotoxicosis. And a mycotoxicosis can take several different scenarios. We see, most of the time, we see some effects on intake, lower feed efficiency. We usually see a production loss. There can be rumen or digestive upsets, intestinal damage and diarrhea. They can also cause nervous effects, organ damage, low tolerance to other stresses. They can reduce immunity and thus increase disease and cause more death, and they can also cause reproductive failure. So you see a lot of different aspects. There are hundreds of different mycotoxins. They all have some different aspect of toxicity, and so you can get all kinds of different symptoms. That's one of the reasons it's so difficult to diagnose, because you've got so many different aspects of affecting the animal. I want to talk about two of these aspects. One is the effect of mycotoxins on the gut, and the second one will be the effect on immunity. We're not going to go into a lot of detail, but I think those two are important aspects to touch on. So mycotoxins will increase intestinal inflammation. They cause a loss of intestinal barrier function. They cause an increase in pathogen growth within the intestine itself. They decrease the surface area of the intestine that's required for nutrient absorption, so we get less nutrients absorbed. You have a malnutrition with mycotoxins, reduced nutrient absorption overall, and then an inability to maintain water balance and thus diarrhea. So if we look at the cells of the intestine, the enterocytes or the regular intestinal cells are affected in that they don't proliferate as normal, so we don't get a replacement of damaged tissue. We don't get that cell growth and intestinal lining replacement that's required, and the lining of the intestine will replace itself about every 7 to 10 days. So there's a very rapid growth in the intestine, and the mycotoxins reduce that growth rate. These Paneth cells within the intestinal lining produce antimicrobial peptides. Mycotoxins reduce that production of peptides, and those peptides are important in keeping the pathogenic bacteria in the gut under control. So those peptides maintain the population of the intestines. Mucus production by the goblet cells is reduced. Cytokines, which are the messengers or the signaling system of the immune system of the animal, these cytokines are affected. They're reduced in production. Immunoglobulins are reduced, and the tier or integrity of the intestine itself is reduced, and I'll take a little closer look at that tier. The tier is a measurement of this tight junction between the interstitial cells of the intestine. Now these cells that line the intestine line up side by side, and there are proteins produced that act like glue in between those cells. And those proteins then prevent pathogens and gut contents from passing from the intestine into the blood supply. So these mycotoxins reduce the production of these proteins, allowing that tight junction to open up and for the contents of the intestines to come in and infect the animal. At the same time, then, bodily fluids like serum can move out from the body into the intestine, and that then would result in diarrhea. So you have a huge effect on the intestinal integrity of the animal. Then what I want to say about immunity, and we're not going to go into detail, this will be another hour's presentation, so we're not going to go into detail on this. I just want to tell you that mycotoxins, one of the big effects is this effect on immunity. And every aspect of immunity within the animal is affected by mycotoxins. So these animals then that are consuming contaminated feed are not going to have the ability to resist disease. Then disease will come in. You will see the symptoms of those diseases, and it's hard then to relate those symptoms perhaps back to the mycotoxins that originally reduced the immunity. So we're not going to go into any more detail. Just suffice to know that the two big effects of mycotoxins, as I see it, is the effect on the gut and then the effect on immunity. These are some of the most important mycotoxins that affect dairy cattle. Ergots, as I mentioned, is a big problem in the Northwest and on into Western Canada. The amount of ergot problem has increased greatly in the last 10, 15 years. It's becoming a big, big issue in Canada. Aspergillus produces a number of different mycotoxins. Of course, aflatoxin is the big one because it is carcinogenic and it is secreted into milk. So it is regulated by the FDA to very low levels. You cannot tolerate more than 20 parts per billion of aflatoxin in feed. The fusarium are the ones that we see the most of, perhaps here in the Midwest and Wisconsin. You see particularly DONs or alanine and T2. Fumonisin and DON are the two most common mycotoxins. They're the two you'll see the most. And then penicilliums, and we'll see the penicilliums primarily in silage. You can get penicillium mold in grain, but in grain, those molds do not produce the toxins that are important to dairy cows. We do see those toxins produced in silage, and they're very, very potent. Okay, we're not going to go into detail about individual mycotoxins. Again, that would take an extra long period of time to do, so we're going to skip through that. Just suffice to know that there are hundreds of different mycotoxins. A paper that came out in 2009 listed over 1,000 different fungal metabolites, most of those metabolites being mycotoxins. So there are a lot of different ones. What I do want you to understand is that if you find one mycotoxin, you're going to find several mycotoxins in the same feed. And this is an example of that. In this study, the researchers looked at 83 different feed samples that had been tested, and at least one mycotoxin had been found. And they collected these samples from all around the world, and they tested them for 139 different mycotoxins. And what they found was that most commonly, if you had one mycotoxin, then you were going to have 20 to 30 different mycotoxins in that same feed. So it's difficult to look at one toxin and say, well, this is the effect of that one toxin, because generally you have multiple mycotoxins that interact and cause symptoms that you may not really expect, okay? So mycotoxins can, again, they can occur in any kind of feedstuff. I think silage is a big problem, but about half to two-thirds of the molds that you see in feeds are non-toxigenic. They don't produce any mold.
We farm about 500 tillable acres.
These are the conditions, environmental conditions, conducive to the production of molds and mycotoxins. They need a suitable substrate, and feed is an excellent substrate. Damage to the feedstuff will promote the growth of molds, so if you crack the corn grain at harvest time, for example, you're going to see more problems. A pH, the molds will grow at a pH between 4 and 8. That's going to be variable by the mold. Temperature between 40 and 100 Fahrenheit. Moisture between, or anything greater than 13 to 15%. So they like moisture. Relative humidity above 70% and a water activity above 0.75. They need a little bit of air, a little bit of oxygen, but they don't need a lot of oxygen. And so in many cases, there's enough oxygen in silage to get them to grow. What causes mycotoxins in the field? Well, first of all, you need spore distribution, but if you look in the paper and you look at what spores are in the air every day, they usually run a list of spores when they're bad because people have allergies to these spores. You see that they're out there everywhere. So spores are everywhere. If you give them the right substrate and the right environmental conditions, they're going to grow. Lack of genetic resistance to fungal diseases. So most of our crops don't have enough disease resistance built in. We need to genetically engineer more genetic resistance into our crops, particularly corn. I think that'll happen. Monoculture is going to increase the problem. Minimum tillage. This is some work from Penn State University where they looked at DON contamination of corn silage. So they've got a 1/2 part per million, 1, 1.5, and 2. They go here from corn grown with moldboard plowing to mixed tillage, minimum tillage, and no-till. So the level of DON went up 4-fold going from moldboard plowing to minimum to no-till. So we see more mycotoxins with no-till. We're seeing that also in wheat and small grain. Stress crops. Anything that stresses the crop in the field will increase the amount of mold. Water stress and insect damage are the two big ones, but we also see with drought conditions or rapid changes in temperature, we see an effect on mold growth. Fertility, anything that stresses the crop in the field. And then silages that are harvested too dry, too mature, or late harvest are also a problem, particularly too dry because you try to put that silage up and you can't pack it well enough to keep the air away. And air is going to be the enemy of the silage. So pre-harvest, we need to use some hybrids that have more disease resistance, that are adapted to the area and resistant to disease and insect damage. The BT hybrids have a little advantage of less mold problems with the BTs. We want to minimize the plant stress. Timely planting and harvest is important. Fungicides are increasing in use. If you look at the data with fungicides, they are very effective. And the recommendation whether or not to use a fungicide is primarily dependent on how much problem you've had in the past with mold and mycotoxins. So if you're in a situation where you've seen problems in years past, your neighbors have seen problems, you might want to look at these fungicides. They definitely are effective. They increase yield of the crop, but they do cost. They're expensive. So that's what you have to look at is cost benefit. In some crops, they're using non-toxigenic competitive molds. This is certainly being used big time in the cotton production. And in this case, what you do is you spray a non-toxigenic mold on the crop. And that non-toxigenic mold inhibits the growth of the wild-type mold and prevents mycotoxin production. This is being used also in peanuts and some other crops. It's moving into corn. With post-harvest mycotoxin control, again, air, water, and pH are the important factors. So with dry feeds, we look at putting up the grain or hay dry, keeping it dry. We can acidify it primarily with chemicals. Then when we look at wet feeds, silage in particular, again, moisture control, you want enough moisture that will exclude the air and allow for a good pack of that mass of feed. You want to eliminate air by covering and packing. And then you can also acidify. Acidification will reduce mold growth. You can either use chemical acidifiers or, as you know, by the simple fermentation of silage, we're producing acids that also acidify the silage and reduce mold growth. That works pretty well, except keep in mind that the penicilliums will grow at a low pH. So we can reduce the growth of Fusarium and Aspergillus, but penicillium continue to grow. So what we look at in silage, we start off here with no air. The sugars get utilized by the bacteria. They produce lactic acid. We get an increase in acetic acid. Those acids will reduce the pH of the silage. And then during storage, if we get exposure to air, then the lactic acid will be utilized and dissipate. The acetic acid declines. They'll get a continual fermentation of the sugars. And this aspect of fermentation, a lot of people call it secondary fermentation. In reality, it should be called deterioration. That's really what it is. And as this occurs, you get a growth of yeast. The yeast generally start off first. The yeast do utilize the acids, increase the pH, and allow for mold growth. And during the growth of these yeast and mold, you'll see an increase or a spike in the temperature in that silage. Looking at this another way, again, air is the enemy of silage. You get a little bit of air into that silo and you can get penicillium growing even at a low pH of 4, which then produces mycotoxins. At the same time, with aeration, you get yeast growth. The yeast will utilize the lactic acid and sugars, produce ethanol, increase the pH, allowing for the Fusarium and Aspergillus molds to grow and produce mycotoxins. So, air again is the enemy of silage. You need to do all of those things that we talk about in terms of making good silage to prevent this problem. The kinds of silages where you're most likely to see problems would be those with a lot of residual starch levels, particularly corn silage, where they've fermented and you still have a lot of starches and sugars available for what most of us call re-fermentation or deterioration. Also, unstable silages would include crops that are stressed during growth. They've been inoculated in the field with mold spores. Silages that are too dry or mature, you can't get them packed very well. Anything that gets aerated because it's not packed, it's inadequately covered. You feed out that silage very slowly. Any silage that's moved and repacked, it's going to be aerated. Some of the worst silages I've seen in terms of mycotoxins were silages that were moved from one farm to another. During spring warm-up and summer, with the warmer temperatures, it's going to stimulate a faster mold growth. So that's also the worst time. We see really two spikes during the year. In the spring of the year, when it first warms up, we see a big spike in mycotoxins. And then at harvest time, when we're cleaning out bins, going with new silage, opening up new silos, that's another time that we see a big spike in problems. Prolonged poor storage and intermediate feeding piles. Now, what I'll say about these intermediate feeding piles, if you start with good clean silage and you move that silage over to the dairy and it sits there for 5 days or a week, then it's probably fine. If it started off good, it's probably fine. But if you take it out of a silo where mold is already growing, you've already got some mycotoxins, then the molds and mycotoxins just continue to grow after it's moved. As a matter of fact, it gets aerated and the growth is even faster. So some of that material can be extremely bad if you're taking that silage out of a silo that's already affected. So with silage management, again, we need to follow all of these recommendations that you've heard all your career about making good silage, choosing appropriate hybrids, ones that have some fungal disease resistance, that are adapted to the region where you're dairying. You need to harvest the silage at the proper stage of maturity and moisture in particular, so that it will pack well. Fill the silo fast, not too fast, because you want to take time to get it packed well. Use the proper chop length. Processing, of course, helps it pack well. You get a high density of packing, cover it well. I like these oxygen limiting plastics. They do a tremendous job of keeping the oxygen out of the silo. Use an effective fermentation aid. Manage the feeding face, and we generally recommend a foot a day fed off of the feeding face of the silo. Now, you might get by with 6 inches a day if you're in a more northern climate, cold in the wintertime. In the summertime, we're in a warmer climate, you're going to need to take a foot a day. Air will infiltrate into that silo deep enough that you'll get mold and mycotoxin production if you don't take at least a foot a day off of that silo. And then don't feed the spoilage. Any of that stuff that's obviously dark and looks like it may have some growth in it needs to be thrown away. Grain storage bins and commodity sheds. We need to handle the feed at less than 14% dry matter. And even at a low dry matter, you can get moisture migration that results in spoilage. So you need to monitor that. It's really hard to aerate these commodity sheds, but certainly in the bins, we need to aerate to keep the air moving through and prevent moisture migration. Clean the bays and bins after use. Use moisture barriers in the floor. Protect from rain and runoff. Monitor for wet spots. If some of the feed gets wet, it needs to be fed right away. Don't let it sit around because it's going to mold. And then rotate the inventory. Don't leave that stuff in the back of the bin forever. Make sure it gets fed out. Moisture migration is an important issue, particularly in bins, because what happens with the heating of the day and then the cooling of the night, you get moisture that will move out of the grain. It will move up here to the top or the sides of the bin. It'll be like a glass of ice water sitting out, it's going to condense, the water will condense on the warm side of that cool surface. So it'll condense on the inside of these bins and then rain down on the grain in spots where you get mold growing, and then it just moves throughout the rest of the bin. So in terms of prevention and treatment, in terms of cropping management, we want to look at genetics that give us some resistance to fungal disease, reduce plant stress, particularly look at the fungicides. There's getting to be more and more use of these fungicides, and I think you need to look at those. Feed storage management, both wet and dry feeds. If you do get in a problem on the farm, it's best to remove or dilute the contaminated feed. Now, dairymen don't throw away feed. I don't care how bad it is. I've worked with dairymen that have had really bad mycotoxin problems. They don't throw the feed away. They're going to feed it some way, somehow. So if you're going to feed it, get it diluted out, maybe use it in with some cattle that are less susceptible, particularly if you have beef cattle or some steers, that it would be the best place to put it. You might, feed heifers because they're going to get such a small amount of grain, and maybe it'll get diluted out. If it's in the silage, you still need to be careful with heifers, particularly those that are bred heifers. Maybe move some of that contaminated feed more heavily into the lower producing groups. Mold inhibitors can be important. At least they stop the mold growth at that point. They do not do anything for the mycotoxin, but they can stop the mold growth. Mold inhibitors tend to be mainly our organic acids, things like propionic and acetic and other organic acids, good mold inhibitors. Extra nutrients in the diet can be important, and you don't really understand this because we didn't go into detail about the effects of mycotoxins, but mycotoxins will reduce protein synthesis in the rumen. You get less metabolizable protein flow to the gut. And a part of the toxicity with things like DON is simply a protein deficiency. Some German research saw a 20% lower metabolizable protein flow in dairy cows exposed to DON. So if you add additional protein to the diet, you can overcome a portion of the toxicity of a mycotoxin like DON. Energy may also be important because when a mold grows in a feed, it utilizes some of the energy out of that feed. So particularly fat, a little higher level of fat added to the diet can add back some energy. Antioxidants can be important. Antioxidants have been shown to reduce some of the toxic effects. And so nutritional antioxidants would include vitamin E, vitamin A, carotene, copper, zinc, manganese, and selenium are all antioxidant nutrients. And then there are some synthetic antioxidants that can be looked at, can be added to the diet. Also, you want to do everything you can to enhance rumen fermentation, to maintain a good rumen fermentation, because mycotoxins are going to be destroyed, at least somewhat, in the rumen. And so if you're feeding these cows so that they don't have a good rumen fermentation, you're going to promote more mycotoxin problems. So we want to maintain effective fiber. You may want to add buffers or make sure that the buffer level you're using is adequate, and microbials may also help in this situation. The two most important treatment products are these last two. We want to improve immunity of the animal. Again, because mycotoxins suppress immunity and you get more disease problems, then you need to use an immune modulator product. These are primarily products that are based on yeast cell wall components, and they are shown to stimulate immunity. The other important product would be a mycotoxin binder or a sorbent. And what these products do are combine with the mycotoxin, and when the cow then eats the feed, as the feed passes through the gut, the cow does not absorb the mycotoxins because it's bound up with these adsorbent products. Now, I have to say, FDA has not approved any products for that purpose, but there's a lot of those products being fed today. So research shows they can be effective. This is an example of the immunity products. What I'm showing here is a simulation of immunity. This would be the normal animal. This would be the stressed animal. Research shows that either in the normal or stressed animal, you can improve immunity with these products. It takes 4 to 6 weeks or so to get the immunity level at the maximum. So you need to be feeding this in the dry cow group so that they'll be ready to resist any problems that they may encounter upon freshening. These are some of the binder products. The binders generally are products like silicates, aluminosilicates. They're grouped into 2 groups, primarily phyllosilicates and tectosilicates. Phyllosilicates are clays, things like montmorillonite, bentonite, smectite, sepiolite. They are layered clays. And because they're layered, they have more binding sites. When they get wet, they will expand and absorb more water, so they do a better job of binding than the tectosilicates. Tectosilicates tend to be zeolites. Zeolites are a structured product. They don't expand in water. They don't absorb quite as much product. Some of these silicates are chemically treated. You'll find some products that are treated with various things, sodium hydroxide or things of that nature. Carbon products, activated or superactivated charcoals have been used. Yeast-derived products, primarily mannose oligosaccharides or glucan type products. They're basically yeast cell wall derived type products that will bind. There are chitin products out there. These are like from shellfish. So those you'll find these kinds of products. And then inorganic polymers or resins. An example of that is cholestyramine. Cholestyramine is a human drug. It's been used in humans to absorb cholesterol. It does the same thing with mycotoxins, but it's pretty expensive, so we don't use it, but that's an example of one of these products. Most of the products we see in use are silicates, yeast-derived products, and then maybe a little bit of the chitin type product. There are also enzymes. There are enzymes that have been discovered that will destroy several different mycotoxins. But enzymes are very specific in that it takes one enzyme to destroy one mycotoxin. And because feeds generally are contaminated with multiple mycotoxins, 15, 20, maybe even 30 different mycotoxins, then those products would have to have 15, 20, or 30 different enzymes. So it becomes pretty difficult, and nobody's really found an enzyme that will destroy mycotoxins just in general. Those have potential. Those have real potential, and if you're dealing with that one mycotoxin that enzyme destroys, they work very well. If you have other mycotoxins that the enzyme doesn't work on, then those products don't work. Now, this is an example of the binder. If you have a contaminated feed, you add an absorbent or binder to the diet, they join together such that joined together, the mycotoxin is not absorbed as it passes through the gut. You don't get any residue in the milk, and the mycotoxin then comes out in the feces, maintaining being bound to that absorbent product. So that's how that works. Give you a few examples of some research where we've looked at binders. This is a study we did with dairy cattle where we fed aflatoxin over a 17-day period. What we're looking at here on the left is the level of aflatoxin in the milk. Remember I said if you feed aflatoxin to the dairy cow, it goes into the milk. So when we feed aflatoxin, we get a spike in milk concentration. As long as we feed that aflatoxin, we continue to have high levels of aflatoxin in the milk. And then on day 8, we introduced binder products. So the green line is control. Those cows receive no product. They continue to have high levels of aflatoxin. The blue line is a yeast cell wall. In this case, we did not get binding with the yeast cell wall with aflatoxin. The red line is a aluminosilicate. And so we saw a very immediate and very significant drop in aflatoxin in the milk. This would indicate a binding of about 65%. Now, I want to show you one more study we did. In this one, we've got 2 glucan products. We've got 2 combination products where they had glucan silicate combined. And then they had, we've got 5 silicates, aluminosilicates. So again, just an example, we're looking at the overall decline in milk aflatoxin. What we found was that this first 3 products did not work. We've got 2 products here that worked. This one did not, and 2 more products that worked to bind aflatoxin. Here's the real point I want to make with this slide. We measured binding in the laboratory in vitro, and you can see that except for the first one, all these products bound 96+% of the aflatoxin. Then we go to the cow. 4 products worked and 4 didn't. If you're going to choose a product to use on your farm, ask for the animal data, because you don't know if the products work unless you look at the animal data. If they show you binding in the laboratory, I don't think it's worth much, okay? So ask for the animal data. Okay, in summary, mycotoxin occurrence is routine. It varies a little bit year to year. It's affected by climate and weather and all this, but occurrence is routine, especially in forages, especially in silage. I think that's where our big problem is, silage. We have a diverse array of multiple mycotoxins in that silage. What we see in dairy cows is a chronic toxicity. Now, that's not to say that you can't have an acute toxicity. We have, at times, you see where a cow eats a moldy, contaminated feed and they get sick the next day or 2. But in most cases, it's a long-term effect, resulting from long-term, low-level intake. So if you've got low levels of mycotoxins in the silage and they eat that same silage for month after month, then the immunity drops, the effect on the gut accumulates, and then you see problems. Even though you've been feeding that for some time, the problem might not show up for months later, okay? So symptoms are diverse. Sometimes hard to relate the symptom back to the mycotoxin, especially if it's affecting immunity and you're actually seeing symptoms of some disease that came in because of the reduced immunity. But symptoms generally will include things like digestive upset, low feed efficiency, production losses, poor reproduction, increased disease, and higher culling rates. Disease therapy and vaccines are less effective. Again, if you're affecting immunity, cows that are vaccinated are not going to develop titers. They're not going to respond to treatments as well. Diagnosis, again, is going to be difficult. Exposure then may be undiagnosed, but a key reason for problems. Important treatments are immune stimulants, adsorbents, and mold inhibitors. And then we've also talked about other management practices that can be supportive and preventive. And again, I want to say that FDA has not approved binder products. So those you won't find any claims on those products if you talk to somebody about them. They are not approved for claims. So that's what I had to bring to you today. I wish I could talk for another hour or 2, but you all are probably glad I'm not. So at this point, I'd be glad to take any questions. Yes, sir.
We're hearing a lot of reports of Mitoxin in Texas and Oklahoma. They're around High Plains region.
Okay.
Panhandle. What can producers do if they have Mitoxin affected corn?
Okay, Mitoxin certainly can be toxic. We fed Mitoxin at 100 parts per billion to dairy cattle. We reduced peak milk production by 20 pounds per cow when we fed that high level. But keep in mind, that's 20 times what it takes to kill a horse. And so you don't normally find Mitoxin at that high a level. The FDA says 15 parts per million is the limit. If you do have those high levels, same treatments as we've talked about for the other mycotoxins. You want to stimulate immunity. You want to use binders and you want to prevent further growth or production in the feed. Yeah. Yes, sir.
Do the silicates or the yeast cell walls work better on the P-monosin, like the differences you have with aflatoxin?
Yeah, and there's, I have to tell you, quite honestly, there's very limited data on a lot of the different mycotoxins that way. And so sometimes we do indeed have to go with the lab results to indicate that there's potential for the products to work on that particular mycotoxin. And so we don't have good enough data to tell you exactly how well they work. As a matter of fact, you know, a lot of these products have never really been tested in the animal, like we'd like to see, yeah. Field indications would tell me that they do work, but that's just me talking to you. I don't have the research to back that up. Yes, sir.
How do you absolutely know what is going on in the gut when all the testing is being done on the outside? Or do you go in and get samples out of the gut and then do analysis on that? How do you tie this down to make sure you're not chasing a false barrier?
Yeah, at this point in time, I'm not aware of any kind of diagnostic of that manner. What we're looking at is gross field effects. You're looking at diarrhea. You're looking at dark manure to indicate blood or irritation in the gut, changes in feed intake, milk production, and so forth. And one of the things that a person might do would be, of course, test for mycotoxin content of the feed. In research, they're looking at biomarkers that perhaps could be used, but the biomarkers are not real good on most mycotoxins. Biomarkers meaning, can you take a sample of some tissue and find a derivative of that toxin in it, or do you find some change maybe in a liver enzyme or something of that nature? And those kinds of biomarkers have not really panned out very well for mycotoxins. So the next way that people have been doing it, and very grossly, is treating for the toxin and simply looking for responses in the animal. And again, the response might be due to a lot of different things, because there's reasons why, if you're using, say, a mycotoxin binder, the cow may respond to that even though they may not have mycotoxins. It may be responding to the fact that that binder is binding a bacterial toxin in the gut. So, yeah, it's kind of conduct your own research and see if you can get a response at this point. I wish it were better. Yes, sir.
Does pig data apply to chickens? Because that's what all the companies come to you with, is chicken or pig data.
A lot of the data out there in the literature is poultry and swine, no doubt about it. And here's the important thing about that is that you take poultry, and they're pretty resistant to things like DON. Swine are very, very sensitive to DON. So you have these species differences that you have to keep in mind when you're doing that and trying to interpolate from one species to another. But yeah, a lot of the information that is known about mycotoxins does come from the monogastric species. Yes. Yes. Sudden death that we talked about in the presentation was the HBS problem. And if you open the cow up and you see that big blood clot in the intestine, it's pretty clear what's happened. It's pretty definitive. You can post a cow right on the farm and see that. Some of these others are very, very confusing because the symptoms, like I say, may be caused by a disease or influenced by a disease, or you may have multiple mycotoxins and you don't see the same kind of effects that you might in control research where you're only administering one toxin. And then the other thing is that, again, just like I mentioned here, with a lot of these tissue effects have really been determined in monogastric animals. So we don't have nearly enough data with dairy cows to look at all these specific effects. Yes, sir.
Probiotics help the rumen kill?
Probiotics can be helpful because they have maintained a good rumen fermentation and a good gut population as well. So yeah, they have been used and can be helpful. Yes. Yes, sir.
If you're sending a feed sample into a laboratory, how do you know if that lab is competent? Is there any kind of testing between labs like they do for, say, accuracy and
Not that I'm aware of, no. So I don't know where to tell you to go to get any kind of an evaluation of how good a lab is in terms of mycotoxin analysis. I'd say most of them that I'm aware of that are doing commercial testing do a relatively good job of that. It's not an easy thing to do to begin with, so they have to know pretty much what they're doing. Michigan State University has on their website there has a list of mycotoxin labs in the country if you wanted to look for alternatives. Okay.
Everybody, thank you, Dr. Whitlow. That was really a good topic for us this year.
Thank you.
So once again, the folks at the Dairy Expo would really appreciate it if you would hand in your surveys as you leave, right at the back door. They're eagerly awaiting them. And on behalf of Feed Supervisor, we really appreciate the opportunity to be a part of this presentation, and thank you all again for coming. Enjoy the rest of the day at Expo.
Nice presentation.
Thank you.
I come from Iran.
Oh, yes, yeah.